Hello, everybody. It looks like today brings us to the end of this class, the close of this class. There's still a couple more days to get all the homework and assignments and final project in. So once again, please remember to get everything to me by 11:59 on Sunday, because that's when all of the assignments will close and lock. And first thing Monday morning, I'll finish up any grading and submit the grades. And I wake up early, so that's usually finished by 7 o'clock in the morning, before most IT people wake up. Generally, at the end of around the time the classes end, I keep my schedule open. So Friday evening, after I finish the time in the office at school, well, on Fridays I'm in the office from 11 to 4. By the way, it's listed on my schedule as administrative hours, so it doesn't go on the syllabuses with a regular list of office hours, but I am sitting in my office, so I will turn on the Zoom call when I'm there tomorrow, except for I think 1:30 to 3 I have a meeting. But I'll turn on the regular Zoom call that the links in the syllabus for if anybody has questions. And at the end of the semester, I always try to keep my schedule open, so if you have questions, I'll basically be sitting around Friday night and Saturday and Sunday, just relaxing and waiting for questions sent my way. So if you have any, please don't hesitate to ask. That's how I've always been, sort of the end of the semester. Just a couple things on the list for today. We've kind of covered a broad spectrum of things in this course. That's one of the core points of this course, and just had a few odds and ends to kind of wrap things up with. I guess one thing on my list here, just because it wasn't directly spoken about in lectures, I want to make sure and talk about it, was one of our learning objectives was just discussing the dissemination of knowledge. That refers to how knowledge is spread, how we get the facts around, and usually instead of just the direct representation of facts, right? Like we'd see in a database, we queried a database, we get those pure facts back out of context and everything. Dissemination usually implies some sort of motive as to how those facts are to be taken. So one of the options for the discussion board this week was to write up a situation about that. And I've seen that go a little far sometimes. What I had in mind was something like news stories. Let's go ahead and share my screen and open something up. So if I was to say, go to CNN.com, how accurate is the information presented on this page? Not very accurate, right? I think most of us know that anything from the news sites, probably take that with a grain of salt. Whenever I feel like looking at the news, which is the news like this, which is kind of random because there's never good news here, I usually look at least both of the big ones. Check out CNN and Fox News, and if both of them tend to say the same thing, there might be some truth to it, but I think you all already know how rarely that happens. I was thinking about things like that when I put the prompt for the discussion board together. The small situations, the news stretching the truth a little, trying to stretch the truth a little bit to push political motives, that sort of thing. But I've seen some people write about big situations. Or the other option on the discussion board this week was to look at some of the keynotes from recent conferences announcing technology and stuff. And there's a similar thing there, right? NVIDIA, the NVIDIA conference is the one I kept referring to. They introduced some really nice technology, some big improvements over their previous technology, rattled off a lot of numbers, talked about their plans of what's coming up. But it's still not a raw representation of the facts like we would get if we just queried a database and pulled up the numbers. right? There's some sort of motive there because that's NVIDIA talking about their own product. It's not full blown to the point we would call it a commercial or an advertisement, but in a lot of ways it is. Is if who's their major competitors? I guess AMD, maybe they make graphics cards. AMD would probably give you a very different take on the new NVIDIA technology than what NVIDIA gave you. So that's what's meant by dissemination of knowledge. We have to be kind of aware of it. I do want to point at a site here, since while we're talking about this, I always like to point at this site. Since I mentioned the news, the depressing news, depressing and upsetting, because they only show bad things, because people react, they get better reactions from people by talking about bad stuff all the time. But there are places to get good news in the world. One that I like to go to and point out to students in class is this site, phys.org. This is a group out of Australia, and basically 24 hours a day, they take the latest research and I guess report on it. They write up, y'all have probably seen research reports, they're complicated, very technical things, hard to follow unless you're an expert in that field. But this group out of Australia, they it's kind of like news for the latest scientific research. They put things down in layman's terms as like a short summary of what it is, summarize the latest research. And it goes constant, 24 hours a day, 7 days a week. There's scientists finding new research. I like to go here for news because humanity seems much more promising when we look at some of the good things, like the latest advancements in knowledge, as opposed to what CNN or Fox News has to say about humanity. And yeah, it's a good thing to look into. Obviously, some of it, they try to put the knowledge into layman's terms, but some things can only simplify so much. Is there any here that would be like that? Oh yes, astronomy would be a good one. This is something that young children often have questions about. So humanity as a whole has a lot of practice at putting that in simplified terms. So they can talk about the exoplanets and stuff. And along with the summary and the layman's version of it, these usually have, that's in the way. These usually contain links to the actual research. So after you read the simplified version, you can follow the link and see what the actual research is about. Yeah, there's a lot of astronomers on this paper, so that one's probably really, really hard to read the actual version of. But that's a good site to disseminate the latest scientific knowledge, the latest advancements. Kind of runs around the clock. Okay, so something like this. Whereas that astronomy one, the layman's term version, is probably fairly easy to follow. Something like this one, you probably have to have some fairly advanced biology knowledge in order to make sense of even the simplified version of it. So there's a lot of that, but I wanted to make sure and point you towards this site. It's a good thing to check out periodically. Keep up on the latest knowledge of humanity. A much better dissemination of knowledge than what the political motivated news channels tend to give us. Humanity seems much more promising when we look at that side of it than what the evening news has to say, basically. And there's lots of different fields. Y'all are heading into technology, so that's a step beyond like those conferences talking about what equipment's coming to store. That's like what the latest, that's the latest things that they've realized are possible. Still a few years away from engineers getting their hands on them and actually applying them. unless it's something really useful that will be applicable immediately. It's like the latest scientific research. Just something to check out. I thought I would share, since I did point at CNN and Fox News and those rare events that I'm curious to look at actual news. I found that can get a better perspective of it, is looking at the two extremes, both ends of the spectrum on those two. So we've talked about a lot of stuff this semester, wide spectrum and all at the introduction level. And it goes a lot further. So I wanted to talk a little bit about things that typically don't get mentioned at the introduction level. It's only 2 pages of notes, so it'll go quickly because it's another kind of like that thing we just talked about it. The simplified version only gets so simple, so usually there's not much about it at all in introduction level, but it does pique people's curiosity and is a big part of modern technology. So I wanted to talk a little bit about AI stuff, just you're probably going to see it somewhere along the way. Artificial intelligence, and in particular, the past few years, there's been some big breakthroughs with machine learning over the last decade or so. So that's the one that kind of shows up the most. Basically, the idea of it is attempts to make machines imitate complex human behavior. Complex human behavior. So when we looked at data earlier, we saw just basically pair matching sort of encoding and representation. That pattern matching, we set up a pattern of switches, and it's predefined what those switches mean. They don't mean anything to the computer. Yeah, I'll draw that one I've drawn a few times. An open switch and a closed switch. Another open switch. Another closed switch. We put switches together in that pattern, and it's been predefined that represents what we know as 5. But it doesn't mean anything to the machine. The machine's just mindlessly following the pattern and matching that pattern to some predefined meaning that a human came up with, because that works well with our numerical systems as we use them, right? We saw all this earlier. Humans have used the column sort of numerical system for a while, and when we go to just 2 possible values for it, we can represent that with on and off switches. But it's still just a pattern. A human completely defined that. And to get complex human behavior, like actually understanding these symbols I'm writing on the board and making sense of that, that would take a whole lot of pattern matching. Basically infinite amounts of pattern matching, something that would be completely impossible. So we need different routes in order to make a machine do this, right? Something that which would be complex behavior. I can just say, make a machine do this and point at the definition that we've already said, and a human understands perfectly what it is. That usage of pronouns. It's like, oh, that's a bunch of big words. I'm going to use a pronoun instead and make it easier to say. That sort of behavior is too much for that simple pattern matching. And getting into the details is definitely beyond the scope of an introduction class, but there's a few things I want to talk about, things you may have heard about. Very early in the days of computers, somebody came up with a way to check it. based off a classic party game. So you may have heard what's called the Turing test. I thought I'd throw out a few terms that you may have heard and explain what's going on with them. It's been modified, but the original one been modified and cleaned up. But the original one was based off a party game, a very popular party game in Victorian England, Victorian age England, the latter part of that, so like 1870 to World War I, maybe a little after. A very popular party game was two people would go off into another room or behind a curtain, somewhere sealed off where a person couldn't see which one was there, and usually distinctly different people. So like, I'll draw a dress here. So a man and woman would go off into another room or behind a curtain somewhere separate, where the person actually playing couldn't tell which one was which, and this person had to guess which one of these was a man and which one was a woman, and to make it harder to guess, one of them would always be lying and the other one would always be telling the truth. And it was based off just questions. So you could ask questions like, nothing's springing to mind. Just asking questions that would normally be different across gender lines. And one of the people playing the game would always be lying, and the other one would always be telling the truth. And they'd like write the answers to the question down on the piece of paper, and you'd have to figure out which one was the man and which one was the woman based off those answers. Kind of like figuring out who's lying. That was the original thought. Humans are really, really good at that. It does not, that's why I was having trouble coming up with questions, because everything that popped in my mind was really, really easy to guess. Just try to think of a few questions without even giving some up. If you had to ask two people, a man and woman, the same question and figure out which one was the man, which one was the woman based off the question, every question you're going to come up with is super easy to guess for a human. This is virtually impossible for machines to do. So that was one of the early things suggested for a way to test when we could call the machine intelligent. When we could start saying, okay, that machine has some intelligence, when it could do this thing that we can do without, that requires almost no thought from us whatsoever. The reason it was a fun game was for the people on this side. So the person guessing, it's really, really easy for a human to guess, but people would have fun on this side, especially the one telling the lies, trying to come up with more clever ways to try and fool the person about their answer. And it's been refined several times. That was the original one based off the old party game. The general premise there in here in 2022, probably even more last year, it's starting to fade, but it's still popular. The general premise should remind you a lot of that game Among Us, right? Figure out who the imposter is. That's based off, that's sort of the latest very popular version of that game that's been around for a very long time. Humans are naturally good at figuring that out, but it's something that gives machines a lot of trouble. And it's been refined with, what is it? That was thought up in the 1930s when they were still, when the idea of a computer was still mostly theoretical. There might have been a few prototypes put together and stuff, but the general idea was still theoretical research. And that was the question they came up with. And so it's had almost 100 years to be refined and improved specifically for a computer, but machines are still really, really bad at that. Whereas humans are really, really good at it. And the reason is another one word that's going to show up here. You'll hear the word heuristics a lot. There's a lot of different ways to take it, but the short one is mental shortcuts. For example, in this game, back in the Victorian age one, where obviously if you hear the sound of their voice, that's going to cover it. But if they're writing their answers down on paper, most people can immediately look and tell whether it was a man or a woman that handwriting there. Right? There are distinct differences. Which interestingly, some research shows goes beyond our species into the other species that we can get to do stuff when we hand them crowns, which isn't very many. A couple of monkeys, I think like the small mammals, like raccoons and possums, do some stuff. Some of the talking birds, like cockatoos and parrots, they'll do stuff whenever we hand them crowns, and it kind of indicates that being able to look and tell whether male or female writing is not solely a human thing. So just writing their answers on paper would usually take the third person joining in the game to get rid of that mental shortcut. We don't even need to see what the answer is. We can tell based off the handwriting of that answer. Even more so usually with the sound of the voice. And there's been a lot of them come and go along the way. A lot of different theories have come, and they might work for one situation or another. The one that's really taken off in the last decade or so, it's okay if I erase this picture. That's the original one. Most people are probably familiar with the game Among Us, trying to figure out who the imposter is. That's basically the modern version, the most modern version of that game. And I'm sure there's some knockoff games doing that as well, but that's the popular one. The one that's really taken off and shown the most progress, especially as machines have gotten big enough to handle it, is machine learning. There is a simplified version on here. The machine, given a big enough sample size, given a sufficient sample, the machine figures out patterns. So for example, well, I'll tie it back to humans. If I was to find a French literature quiz or test from like a class in a French literature class, y'all probably don't know a lot about French literature, right? Maybe some basic stuff, but I can find an advanced college class on French literature and pull out their exam that most people probably wouldn't know the answers to. And then what if I translated that quiz to Chinese? We're Americans, so I'm assuming nobody speaks Chinese or reads Chinese. So you have and I gave you this test about French literature written in Chinese. You wouldn't know what to do at all on it, right? You would be like, well, you have to figure out something. So you just be like, okay, whatever, mark a random answer on every question and turn that in, right? That would be something. If I graded it, told you which ones are right, which ones are wrong, then gave you the same questions again. Let's see which ones are right, which ones are wrong. Gave you the same questions again, only maybe in a different order, and repeated that process. You probably still don't read Chinese from seeing just that one exam paper. You probably still don't need no French literature from reading one exam written in a language you don't speak. But after a few times, you might pick up some patterns. You wouldn't actually be reading Chinese, but you'd start to spot some patterns on the questions that you randomly guessed right. And if we did that over and over again, eventually you'd be getting the right answer on those quizzes, even though you don't read Chinese or know much about French literature. That's how machine learning works. Eventually, the machine can figure out how to spot patterns. So it's still pattern matching, like that thing that we set up earlier, only it's not a human developing the pattern. The machine develops the pattern. And sometimes they seem really odd. One of the basic examples of that is recognizing the digits, learning to read different people's handwriting. And for some reason, when machines are learning to recognize the number 4, one of the most important things they look at is a bunch of diagonal lines with some cross-hatching in it. They look for a pattern like that, and that turns out to be one of the most important things for recognizing any 4s. It looks, let me try to draw that more carefully. They look for what looks like to us a bunch of overlapping 7s. So it doesn't make much sense. A human would have never guessed that pattern, but that's one of the most important patterns for a machine to learn to recognize 4, no matter who wrote that digit, who wrote the 4 down. But it's still basically pattern matching. And that's where the biggest breakthroughs have come in the last few years, because it's creating simple patterns, which are small instructions. And one of the things that has driven up the price of GPUs, because they're small, simple instructions, not big, complex calculations. So it's better suited for processing on the GPU instead of a CPU. A really large workload. A good comparison on an analogy to make is comparing a Ferrari to a van. A Ferrari is almost always going to count better than a van, except for moving day. A Ferrari is pretty useless when you need to move to a new apartment. Right? You might be able to haul your alarm clock or something, but not much. A van is much more useful that day, and a GPU is like that. As a the CPU is always going to be faster and be able to do fancy things better, but a GPU is huge and can do lots and lots and lots of simple things simultaneously. So for machine learning, that kind of showed up. In particular, neural networks, which I mentioned that's one of the most important patterns it looks for. Those are the ones that have really taken off and shown promise. I'll draw a picture up here. Is it okay if I erase this side? Hopefully those words have been up there for a minute. To give you some sort of idea of what's going on with these, we'll have some sort of input. I'll draw it like this. We have some sort of input to the machine, and eventually we're expecting output. And in between them, the traditional processing, like we talked about earlier this semester, was that simple human-based pattern matching. Humans use the numerical system we've used for centuries to line things up in columns and then do everything with base 2 mathematics, and then correspond things back to that base 2 numerical value. But that might not be the best way for a machine. So people tried different things, and one of the things they tried is like a neural network. And they were progressing along nicely until around 2012. There was a big improvement in GPUs, and that led to much larger workloads being able to pass to a GPU. And then neural networks really took off. Because what it does is it takes the input and sort of, it looks like this. I'll draw like 3 in the first level. So it splits it up into different sections. Maybe on a picture, trying to figure out what this 4 means. It might split that up like a grid. Put some colors over there. You can still see the original. Might split it up into a grid. I'm just going to draw 3 for simplicity in the picture here. So it would take forever to draw a big grid like this because the next one gets bigger. And then it analyzes what's going on in each pixel. So there's emptiness there. There's a little bit down in the corner, but that's probably just overlap from something else. Same thing here, a little bit of overlap from something else, another empty one, and analyze each one of those. And then depending on that situation, it splits it up again. I'll draw 6 this time. 3, 4, 5, 6. And there's like 6 different things that can be analyzed from each one of those pictures. So on each of those initial splits, it'll kind of figure out somewhere to put those. Kind of split up those inputs into another chain, and there'll be like several of those. I'll show you dot, dot, dot. We can have several layers of those. Each one gets treated as an input and then move to an input for another specific input. You know, draw a couple lines. Eventually they sort of coalesce back on something. And after it gets through all that jumbled mess of inputs become each layer, the output becomes a new input. Each layer also has a different weighting, like how important it is. Maybe our initial split, the one the humans came up with, is only about 10% of how important it is. And this one would be like 17%. And so on through there, and what's that? Then by the time it gets to the last one, what is that? 27. So there's 73% left to deal with. And maybe this is the one where we choose our output, and then we can get a weighted average. We take what it was this times how much it's worth, sort of like a GPA. That's the most common weighted average humans are familiar with, or college students are familiar with. An A in your welcome to college class, the IBYT 115 class here, an A in that class is not going to affect your GPA nearly as much as a C in a physics class, because your physics class would be 4 or 5 credit hours, and your welcome to college class is 1 credit hour. So one of those classes is more important, regardless of what the grade is. If you get the same grade in both of them, the physics class would affect your GPA a lot more. So there's different weights assigned to each one, and neural networks are kind of built up on that. Calling it a weighted average is a massive simplification. It's thousands and thousands of weighted averages built, so it's a lot more complex than that. But maybe on this last one, those are assigned values. So if we're looking at this digit here, maybe that's 1, 2, 3, 4, 5, 6. I only wrote 6, so I'll just use those digits, some of the digits, but that would just expand out for 0, 7, 8, 9. And from the lines I drew here, which I was kind of drawing arbitrarily, we split it up, and it looks for certain patterns in each section of the split, adds some sort of weight there, and keeps doing that over and over and over again, and finally gets that output. In this case, it looks like the computer would guess that that's a 2. It's like, oh, I'm looking at a 2. Then we can look at that and say, nope, that's wrong. Not a 2. Then the computer comes back and adjusts this. Like, okay, this one might be too high. So let's back that off and increase the importance of this one. Maybe jump that from 17 up to 29%, 39%. So then this one's at 61%. Runs through that same thing again. It looks at the same inputs. So the initial split's the same. Goes through different layers. Some of them might come out differently. There's little changes along the way. And somewhere in here, then the second time through, or probably more than the second time through, eventually, kind of like that French literature quiz written in Chinese that I just mentioned. Hopefully that was an easy one to visualize. Eventually, the computer is going to get these weightings right and figure out which little patterns are the most important to look at to figure out what the correct answer is, and eventually say, okay, that's looking at a 4 there. So a trial and error, it's still essentially pattern matching, only the computer makes its own pattern. So obviously it's very, very optimized for what a computer is going to do. The pattern a human came up with is probably not the best one for a machine. So when we let the machine figure out the pattern on its own, it's going to get much better results, but it takes a long time for the machine to figure that out. We have to have very large data sets, and the data sets have to be prepared for the computer. They have to be, we have to get that first input section split up right, because the computer can't deal with just anything. So when it comes to working with these things, training new models, once the model's trained, once it's saying it's for a reasonable amount of times, then we release that model, and anybody else can just show that model a 4, and it's probably going to guess it right. Usually not 100% of the time. If it says 4 100% of the time, that means we spent too much time training and it just memorized our data. That's the opposite of learning. If it's saying 4, if it's saying that's a 4 75% of the time, that model is more accurate than not. So we would go with that. It hasn't completely memorized the data that it's been shown, but it's been able to figure out what that data is with reasonable accuracy. And handwriting is a good example of that, because humans get that wrong sometimes too, right? I have awful handwriting. I know more than once this semester there's been a question pop up like, what's that word say on the board? We are very, very good at figuring out what those patterns are, and still have to ask that question. So 100% accuracy is definitely a problem. We wouldn't expect the computer to ever get everything right. So most of the work, once it's ready, it's ready. Most of the work is getting this first set, like this first row here, ready. I have one more thing to write. Is it okay if I erase this side? But I wanted to talk about this as far as at the introduction to IT class, because there have been big breakthroughs in that over the last decade. So you all will definitely encounter machine learning at some point. The thing about this, getting it ready, is this is where human work is involved. We have to make things ready. So the typical data I use in classroom examples, you all have seen that before. I'll make a table of that. Name, age, town, and I'll add one more in here, maybe favorite color. That'd be a good short list. So if we have a table filled with data that we will need to work with some sort of training a neural network on, we'd have things like name, Chris, I'll read my name. I live in Clarksville, and I'm gonna do a short list on color green, and I'll make up a couple people. These are not real people, I'm just making up names. And there's 16, lives in Louisville and likes the color blue. And Dave's 54, lives in New Albany and likes the color red. So some of this the computer can process immediately, right? Our age data, I'll just write a check mark. Our age data is numerical directly. The computer has no trouble with that. The other stuff might be a bit of a problem because these are that representational sort of data. So the computer, that's a bunch of numbers, and it was just told that those numbers are ASCII code this time to spell out a string. Same thing with towns or favorite colors. So we'll have whatever our data set is, and a programmer has to come through and modify the data so that we can use it in this process, which has certain restrictions. One of those being it has to be that core level processing, like what an arithmetic logic unit could deal with, which means everything has to be numerical. So we have to somehow come up with adjustments for our data. So like in the town, if we're talking about one region, those of y'all who live elsewhere in the state might not recognize those names, but those are all close towns here close in the same vicinity. All three of those towns I mentioned have borders right up to each other. Like welcome to our town and leaving our town signs are right next to each other. So when we have something regional like that, we could give each one a numerical value. We can say, okay, start at the southernmost one, then give that number 1. And then as we move north, we'll go like left to right, like we would read a sentence. Actually, we'll probably go the other way. Read it like a sentence, we'll go left to right, top to bottom, as it would be on a map. So from these 3 towns I wrote, some of y'all might live elsewhere in the state, but Clarksville has the points furthest north of those 3 towns. As we go down, move southward, New Albany would be the next one we come to, and then, so actually the other way. Because the river is flowing somewhat southward, Louisville has some parts that are further north than New Albany. And going down the map, but some arbitrary value. We know what it is. If we need to work with, if we as humans need to work with it, we don't want to erase our original data, right? We're modifying a copy of it. But those letters are meaningless to the machine, so we have to change that and give it some sort of meaningful value. It can be anything we want, as long as it gets to a numerical value the computer works with. Or another common thing is to do what's usually referred to as one-offs. That's basically if we have a short list, make it Boolean, give it Boolean values. So this favorite color column, let's just assume for simplicity that those are our only 3 colors. People have to choose a favorite color from red, green, or blue, one of those 3. What we could do is turn that into 3 columns on our database. I definitely ran out of room there. A red column, a green column, and a blue column. And then replace each one with a true or false value. So this first row, the favorite color is green, so that would get a true, and the other two get false. Or the second one, blue, so that one would be true, and the other two would be false. Same thing on the last one. True on red, and then false on the other ones. And we cleaned up our data so that now all of these are numbers, so the computer can go through this weighted average process, which is an oversimplification to help visualize what's going on. Because when we're talking about tens of thousands of simultaneous weighted averages, we're not going to call it a weighted average, like when we think about our GPA, but it still follows suit from that. Lots of different values assigned, and then we adjust those values until we're getting the correct prediction. And then for this one, we're probably not going to be predicting names, right? Names are an arbitrary choice given by our parents at date of birth. Names don't really tell us anything about this other information. The others are hard set informational facts that might be related. If we're talking about Florida, there's probably a higher average age because that's where people retire to. Especially people from New England, which is very, very overcrowded, which lowers the average age in New England and raises the average age in Florida. So something we could make predictions with between age and the place where people live. This one kind of arbitrary, but it was trying to simplify the example here. But we're not going to be using somebody's name to predict something about them, or vice versa. We're not going to be trying to predict somebody's name because that was an arbitrary decision made by the parents and parents. So we'd probably just get rid of that altogether get rid of the names altogether before passing it in here. Unless for some reason we wanted that in the output, in which case we'd leave something here that would correspond to it, but probably get this out of there still so that there's less data for the machine to process through. But that is the working side of it. And something where there's a lot of work for, because the research aspects of machine learning are kind of wrapped up. They've got some really good things in place. The high-level researchers, I guess some people with masters and a lot of people with doctorates in computer science, have finished out the research, got all the equations and the setups ready. So now it's just a matter of going through the database and cleaning up the data so that it can be worked with in this case, and accurate predictions can be made. But cleaning up a database is not the sort of work people with a PhD in computer science are going to do, right? Hopefully those words just sounded a little off when I said it. Right? Somebody with a PhD, a 9-to-5 job of cleaning up and modifying and inputting and querying a database is lower than the highest education level for computer science. So the people that know this stuff, they're not going to do that daily grind 9-to-5 job part of thing. So this is something where there is work available in data analytics, getting all the databases, getting big data ready for machine learning algorithms. There's a lot of work in that. There's actively things trying to get that rolling at the community college level. Several small community colleges I know already rolled it out, but Ivy Tech's a big community college. I think everybody's aware of that, right? There's only one community college in Indiana, and it stretches all the way across the state at many, many campuses. So it takes us a minute to roll things out for that many people. in Indiana, our community college is big enough that sometimes the state Congress has to make decisions because it's going to affect so many people in the state and bordering states, because there's a lot of people in Chicago and Louisville and Cincinnati that do cross the border into Indiana for Ivy to attend Ivy Tech courses. But some smaller colleges have started rolling it out. Intel directly developed a curriculum themselves. They're like, this has got to be done. So they put together a community college curriculum and then brought that around. So really what the rollout is customizing and modifying that. But it is something that's definitely on the way. So if you're heading into an IT field now, this is something that you're likely going to see a lot of good paying jobs for in your future. And it's a lot of data analytics work. Data analytics and a little bit of software development. Something to think about, which brings us to the last thing on my list to talk about. Oh, natural language processing is similar. It looks for patterns, only it looks for patterns in sound waves instead of the pixelated like I drew with the 4 earlier. A very similar thing, and to work with that, we train our models in a similar way. So those generic concepts I just talked about would still apply. But then when we get to the output, we use a markup language. SSML is kind of the standard. That's what Siri and Alexa and Google Assistant all use. So anything else should probably be using the same thing as them, or programmers aren't going to bother to learn it, right? So it's a markup language like we saw in the HTML section in module 4, I think. The markup language where we add little tags in to add different level of emphasis to words and decorate the words instead of that raw robotic speech, which is kind of famous in our society, to get to those things like Google Assistant is consistently fooling humans as to whether they're talking to a human or a machine anymore. Those little things. The other ones are a little bit, but Google Assistant is better because Google Assistant will get annoyed with you. It will start sighing and grunting and losing patience, and that really helps with that Turing test thing. Fooling a human as to whether they're talking to a human or a computer. Because, it sighs and grunts and gets impatient with you. Little things like that are handled with a markup language, but the models are trained in a very similar fashion. When you have a class on machine learning, you'll cover both the visual and the audio the same in the same sections, basically. But a lot of different things we've seen this semester, right? I just tied in some stuff. We talked about data, and while machine learning, right, is super fancy, there's a lot of research still going on to achieve that goal. There's been a lot of progress, and now there's day-to-day jobs. So for us at a community college, that day-to-day work, which is cleaning up a database and training models, we're not developing new models and new theories. We're just cleaning up the database and training the models. That's the sort of work that is going to be very, very prevalent for community college IT graduates heading into the future. So data analytics is a good option there. One of the things this class is about is surveying all of that stuff. Right? Everybody here is in the IT program, heading towards some sort of IT career. So hopefully this class gave a little taste of what you're heading into. Right? We saw hardware and software and data, some database stuff, cybersecurity, networking stuff, virtualization. All of our major IT programs were sampled in this. So hopefully when you saw that section that relates to your program, you felt like you were really in it's like, oh yeah, I like this lab. I'm definitely feel like I'm in the right place in the cybersecurity lab, a cybersecurity program after finishing that lab. So hopefully you felt like that. If not, make sure you're heading into the right program. Any place in IT pays well. Some obviously pay better than others, but basically any of the fields you're heading into for IT degree are going to come with a decent paycheck, and happiness is worth a lot. So if you're going something purely because it has a slightly bigger paycheck than the one you're interested in, keep in mind that happiness and interest factor that you would be losing there. Happiness is worth a whole lot, is a note I wanted to make. And if you saw something else in this class that caught your interest that you'd never really thought about, keep that in mind. Talk to your advisors about it. The full-time faculty at Sellersburg, so me along with some others, know a lot of the fields that we teach, and if one of them caught your interest, let us know, or the academic advisors at the school, and talk to somebody about it, about, well, maybe that would be a better program. That's part of the reason everybody has to take this class. Part of the reason there is no testing out of this class, because at times you probably felt like it was oversimplified, right? I believe one of the reading assignments told you what a mobile phone was, but you could not possibly have gotten to that reading assignment without multi-factor authentication. So you had to use a computer and a mobile phone simultaneously to get to that reading assignment. That's probably the best example I can think of there. So some of them seemed very base level, but it was supposed to be a sampling, a survey of all of IT, not just the particular field you're going into. That's why everybody has to take this, and there's no testing out of this class to kind of ask that question here at the end. From that little sample that we got in this class, do you still feel like you are in the correct program, the one that matches your personality, matches your interest? And my closing note on it is everything in IT pays well, and happiness is worth a lot. So if it's only a slightly bigger number in that paycheck, keep the happiness factor in mind. And that was it for what I had on the list today. So I guess that kind of wraps it up for our lecture time in class. Does anybody have any questions before we wrap up for today, or, well, for the course? All right, I see some no's popping up in the chat room, and I assume 5 seconds of silence means no questions. So next week is a week off, and then the second 8-week term starts. Everybody try to relax some. I know you've worked hard. Please get all assignments to me by Sunday at 11:59 p.m. It's been a great semester. Thank you all. I hope to see you around soon.